All right, let's find the function, the power function that passes through these 2 points. Okay, so I'm going to start this one. I'm going to say, well, I know that that's an x, that's a y, and that's an x, that's a y. So I know this has to be true. I know that 80 has to equal a times x to the p. And I know that y, 3125, equals some a value times 5 to the p. Okay, so the first trick we're going to do is divide both sides by this exponential piece to solve for a. And then look what we have. We have a equals 80 over 2 to the p, but a also equals 3125 over 5 to the p. So since these are the same a, I can just equate these two parts of the equation. I can just say this equals this, since they're both a. Okay, so that's where we're going to start. So 3125 over 5 to the p equals 80 over 2 to the p. Now what I'd like to do is get one p, all right? So that is, I want to get all the p's on the same side, but it's an exponent, so we got to be careful. I'm going to cross multiply. 3125 times 2 to the p equals 80 times 5 to the p. Okay. I don't need these parentheses, but it helps me group my expression. So if I divide both sides by 2 to the p, if I divide both sides by 2 to the p, then that's gone. And then over here, I got the p's on one side, so that's good. I can also divide both sides by 80, and I end up with 3125 over 80 equals 5 to the p over 2 to the p. Okay. If I ever have a fraction I can reduce, I want to do that. So I see 3125 over 80 should be reducible. I'm going to use my calculator to help me figure that out, but I know that 5 can go into both of those at least. So if I divide them both by 5, I should get 625 over 16. So divide by 5, I get 625 over 16 equals 5 to the p over 2 to the p, but you can also, if you really want 1p, 5 to the p over 2 to the p is the same thing as 5 halves to the p. Doesn't matter. However, you can get your answer. Okay. Now this next one down here, it looks a little more complicated, and even this third example I have here also looks more complicated because of these fractions, but it works the same exact way. The only difference really will be, at least for the first part, will be that will be a fraction divided by a fraction. So we'll have to figure out how to do that, and I'll do that in the next example. But my point is, you'll get to, for all these problems, you'll get to something that looks like this. You should have a something to the p equals something. May or may not be a fraction. A lot of times it is. And at this point, usually we solve these equations with logarithms. We're going to learn that later this semester, because my variable is an exponent. But we don't have logarithms yet, so it's kind of a trial and error thing. So if you look at this fraction, you could ask yourself, 5 to what power gives me 625? And whatever that is, 2 to that same power should be 16. That's what p is. So it's a little bit of trial and error, so I would focus on the 2. So I say 2 to the third is 8, 2 to the 4, with maybe a little bit of guessing and checking. I say, well, wait a minute, 2 to the fourth is 16, so I'm pretty sure that's my value for p. As long as 5 to the fourth is also 625, which it is, meaning that 5 halves to the fourth is 625 over 16. Okay, so we just decided that p was 4. And again, it's not the best mathematical approach. We're doing a little trial and error, but that's really the only option we have. So that gives me, for this thing right now, my answer is, when I'm still not done, y equals a times x to the fourth. So I still got to find a, because those are the directions. Find this and this, x and y, or x and y. There are variables. So now I'm going to take either of these 2 points and plug it in. Doesn't matter which one. I'll choose this one. I'll say 80 equals a times x to the fourth, and that'll let me solve for a. And I'll get the same value for a if I use the other point. It doesn't matter. So I'm going to choose the smaller numbers, easier to work with. 2 to the fourth is 16. Divide both sides by 16, and I get my answer for a. A equals 5. That means I put a 5 in for there, and I have my final answer. And we can check to make sure if I want this point should satisfy this equation, but this one also should satisfy this equation. I'll leave the check up to you. Okay, now let's do one. Here's what's different about the next one. It has fractions as output, so we'll have to divide by fractions, which isn't a big deal. I did this one ahead of time. The big deal for this one is I think p is going to be negative, which is a little tricky, but I'll show you that when we get there. For now, everything works the same, so we do it just like the last problem. 3/4 equals a to the 2 to the p, or a times 2 to the p, but also 2/9 equals a times 3 to the p, and I could solve for a in both cases by dividing. Okay, and then I equate those two things. So I got a 3/4 over 2 to the p equals 2/9 over 3 to the p. Cross multiply. So my 3 to the p will be here. My 2 to the p will be here. And then divide both sides by 3 to the p. So I now have 2 to the p over 3 to the p equals, divide both sides by 2/9. Sorry, I know I'm skipping a couple steps, but hopefully you'll follow this. It's just like the last one. Just like the last one, only I have to deal with this fraction. Okay, so let's do a quick review. 3/4 divided by 2/9 is equal to 3/4 times, remember you multiply by the reciprocal. Whenever I divide by a fraction like 2/9, it's the same as multiplying by the reciprocal 9/2. So we always leave the first fraction as is, or the top fraction as is, and we multiply and we flip the bottom fraction around. That gives me 27 over 8, which I can't reduce. Okay, so now I'm in the same exact place as I was in the last one. I got one fraction. Okay, and what we did in the last one, we said, okay, it's a little trial and error. 2 to what power gives me 27? And 3 to that same power should give me 8. But this one's tricky. You might notice that 2 to, there is no power. 2 to some power gives you 27, right? 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. We skipped it. However, you might notice that 8 is a power of 2, and 3 to the third is 27. Or in other words, 27 is a power of 3. So I got them backwards. So what happens? How do I raise 2 to a power and get a number in the denominator? It would have to be negative. So at this point we say, well, wait a minute, p has to be negative. Okay, and again, it's a little trial and error, but if I say, well, 2 to the third is 8, which means 2 to the negative third is 1. 8 puts the 8 in the bottom, which is what I want. And then over here, I would say, well, wait a minute, 3, is this going to work? 3 to the third is 27. 3 to the negative third is 127, but this 3 is in the denominator. So if I separate it, does this make sense? 1/3 to the negative 3, does that equal a 27 up top? And it does if you remember your rules of exponents. The negative exponent flips it around. So that does make sense because 2 to the negative 3 is 8 in a denominator, and 3 in the denominator to a negative 3 is 27 in the numerator. So that allows me to figure out that p is negative. Okay, so now that we know that, 2 3/4 is my point, so I got y equals a x to the -3, and then 2 3/4 is my point. So let's see if it works out, if I can find a without too much trouble. So that means 3/4 equals a to the -3rd is 1/2 which is 1/8. And I divide both sides by 1/8, which we just got practice with. So this will allow me to solve for a. A equals 3/4. Let's come over here. Let's come over, where are we? Here. 3/4 close header for, okay, sorry for the delay. Right here, I'll finish the problem. So I had 3/4 over 1/8. 3/4 divided by 1/8 is 3/4 times 8/1, and that should be equal to my a. So let's see, 4 into 4 once, 2, so a should be 6. All right, so y equals 6 times x to the -3. Close header, -3. Okay, so the finding a is not that bad. This one is tricky. I mean, the process for all these is going to be the same. It's right here. You should always get a statement that looks like this for all these problems. And if in the first example, it was this right here, where it was kind of easier. It said, well, the 5 and the 625 are both in the numerator, so I knew p would be positive, right? I say 5 to the 4th, and the bottom 2 to the 4th, and it works out. But if it's kind of flipped around, like this one, I can recognize that 2 to some power will give me the denominator, and 3 to some power, if 3 is in the denominator, give me the numerator. Then I have to kind of recognize p is negative. And then it shouldn't ever be that. It shouldn't be anything else than like the exponent 2, 3, 4, or 5. Right? Because if they get too big, then it just gets too complicated. So before we get to logarithms, then they shouldn't be too bad. And once we recognize it's negative, we can kind of figure that out. And the last step will always be the same. In order to find this value for a, plug in one of your points. Okay, so hope that helps. But if you have more questions, let me know.